solving equations with variables on both sides. So as soon as you have variables on both sides, that opens you up to more possibilities of the types of solutions that you'll get. So the types of solution that we've been working with so far is when we have one solution. That is when you have your variable equals a constant. That is when the variable equals only one number. For our cases, that is still going to be the most common type of solution. We also have cases where you might have infinite solutions. That is when you have two numbers that equal each other, two variables that equal each other, which just means that you'll have infinite solutions. Pretty much, infinite solutions occurs when you have the same result on both sides. We'll look at examples like that. Then we'll have cases where you have no solutions. That's when we have two things that are not equal, which would be like 4 equals 11. Obviously, those are not equal, which would leave you to no solutions. We represent no solutions as a 0 with that's crossed out, or you could just write no solutions. These are scenarios where, oops, that was a bad W, where we get different results on either side. Pretty much the two constants you get are not going to be equal. Okay, let's look at a couple of examples. So just like solving any other equation where we want constants on one side and variables on the other, variables on both sides works the exact same way. So we can either move our constants or our variables first. Since this is the first one, let's start with variables. So I'm going to start by subtracting 4k from both sides in order to get my variable just on the left side. That's going to give me 3k plus 2 equals negative 10. Now that my variables are on the left side, I'm going to subtract my constants to the right side. So I'm going to subtract 2 from both sides. So then I have 3k equals negative 12. This is something that's far more solvable. From here, I'm going to divide my coefficient, divide both sides by 3, and that's going to give me k equals negative 12 divided by 3, which is negative 4. And for this one, that is a one solution example. All right. Once again, I'm going to do the examples on the right or on the left. We're going to save the examples on the right for class. So do those on your own. On the next example here, you can see I have a multiplication outside of parentheses. So the first thing I would do here is use the distributive property to undo those grouping symbols. So that's going to give me 5y minus 4 plus y equals 2 times 3y, which is 6y, 2 times negative 2, which is minus 4. From here, I'm going to combine my like terms since I realize I have y multiple times on the left side of my parentheses. So I'm going to combine my like terms to simplify my equation a little bit. 5y plus y is going to give me 6y minus 4 equals 6y minus 4. Some of you may see where this is going. Just like the previous example, I'm going to go ahead and cancel out, move all my variables to one side. So I'm going to subtract my 6y over, which will end up canceling out on both sides. This is going to leave me with -4 equals -4. Obviously, -4 is equal to -4. That's a true equation. So this is one of those cases where I'm going to have infinite solutions. And that's my final answer here. All right, let's take a look at this bottom one. And this is actually supposed to say +4. I totally had a typo there. So just like the previous example, let's start by distributing our -4. -4 times 3n gives me -12n. -4 times +4 gives me -16, which equals -12n minus 8. This one is a little bit different than the example before. Once again, let's move all of our variables to the same side. So I'm going to add 12n to both sides. This will end up canceling out on both sides as well, which will leave me with -16 equals -8. This is obviously not a true statement, so I'm going to represent that by slashing through my equal sign. And since they are not equal, this means that I have no solutions. Okay? So we just went through one example of each of the three solutions that you may get. So on the second side, we are taking a look at cross multiplication examples. These will be like the proportions that you will solve in geometry next year. So when you have fractions on both sides of the equal sign, that's very important, both sides of the equal sign, you can undo your fractions by cross multiplication. So that is where you'll multiply 3 times x and 4 times 6. Doesn't matter which side of the equal sign either go on. So I'll do 3 times x first, which gives me 3x, which equals 4 times 6, which is 24. Now I'm going to divide my coefficient of 3 to solve for x. So divide both sides by 3. And that's going to give me x equals +8, which is my final answer for that one. We're going to save the other two for class together. Actually, no, we'll do the second one and then we'll skip the next two. So you can see in the second one, once again, we're going to use cross multiplication, but this time I have multiple terms in my denominator of my second fraction. So when you have multiple terms, you're going to want to multiply using parentheses. So I'm going to have 2 times parentheses n plus 5 equals 10 times 4, which is 40. Now I'm going to solve my equation. I'll start with distributing my 2. So that gives me 2 times n, which is 2n, plus 2 times 5, which is 10, which equals 40. From here, you're just going to solve like any other equation. Start by moving my constant to the other side. So I'm going to subtract 10 from both sides. That gives me 2n equals 40 minus 10, which is 30. Now I'm going to divide my coefficient. So divide both sides by 2. And that's going to give me n equals +15. So make sure you're using parentheses whenever you have multiple terms. That is the case for both of these last two cross multiplication examples. And I'm going to save both of those for class. Another question I'm going to save for class is this final application problem. I want you guys to make sure you write this down ahead of time, and then we'll work through it together in class. All right, thanks for watching. Please try the other examples on your own. These take some practice to know all of the steps and the correct order, so make sure that you're doing some practice on your own. All right, thanks for watching.